Unser Keynote-Speaker Paul Atkinson ist ein international anerkannter Experte in der 3D-Drucktechnologie. Er ist Industrial Designer und auch Designhistoriker. Er war vor seiner akademischen Karriere auch als Designmanager und als Direktor einer Designberatungsfirma tätig. Zurzeit unterrichtet er an der Sheffield Hallam University in England und seine Forschung erstreckt sich über die ganze Bandbreite der Themen, die sich mit der Beziehung von Gesellschaft und Technologie beschäftigen. Also eigentlich ein wunderbarer Anschluss an deinen letzten Satz, wo man sagt, es geht auch darum, gesellschaftliche Prozesse mitzugestalten, zu beobachten, einzugreifen. Also es geht ja weit über dieses reine Produktionsthema hinaus. Das heißt, da sind wir jetzt sehr gespannt, was wir da hören werden. Paul Atkinson will tell us about the changes in 3D printing and about how these changes will affect different spheres like technology, labor ethics, or new cooperation models. And so we are very curious to hear more about the possibilities of this craft of the future. Paul, the floor is yours. And this is your water.
Well, good evening, ladies and gentlemen. Can everybody hear me okay? Okay, thank you. Well, first of all, I'd like to say thank you for the invite to come and talk here tonight. I'm honoured to be asked, even though it can be quite daunting sometimes when you're talking about some of these technologies when they change so quickly. And I think we'll come on to that quite soon. Just a little bit of background. I work in Sheffield Hallam University in the Art and Design Research Centre. And we do a lot of work in design for healthcare. And this is me down at the bottom, this little pair of spectacles down there. And if you click on that, it gives a page and tells you about various projects that I do at the university. One of which is post-industrial manufacturing. I run a research group called Post-Industrial Manufacturing. And I'm surprised myself that I actually started that over 10 years ago now, when I was working at a different university. So I've been working in the area of 3D printing and rapid prototyping since about 2000, 2001, very early stages. And the first project that I did was to engage an industrial designer and a computer programmer and put them together and ask them to produce a system that could do something quite special. And you'll have to remember, this is over a decade old now. So the idea for the design was that a consumer, instead of going to a shop and seeing a fixed product, would go to a website and would be able to see a series of designs of objects. And then they could click on that design. And when they did, they would be presented with a moving image of that product. And what was happening here, this is just an animation, it's not the actual software. What is happening is we're using the computer to randomly generate the form within an envelope designed by the engineer, the designer. He's specified the parameters within which the design can mutate and change. Now, the consumer has no control in this system. The consumer has no control, but what they can do is at any point in time, they can just click and stop the animation. And when they do, they end up with a unique 3D model that can never be repeated because of the design of the system. And if they like it, they can rotate it in 3D, click a button, and they can send it to a 3D printer and have it made and delivered to them. That was the initial idea. And we also did this other design of a lamp. So quite easily assemblages we could put together and make the forms quite complex, and yet they could never ever be repeated. And people were very interested in the idea, but it was this idea of uniqueness, and also another idea we had was this one at the bottom here, which was like a light bulb with little nodules on it, which were LEDs. And when we would run this program over 6 months, a set period, like a limited edition. 6 months. And at the start of the 6 months, it would be perfectly smooth with just some little LEDs on the surface. And then over time, those would grow and expand and branch. And by the end of the 6 months, it would look like a small forest full of little LED strands. You could never go back. You could keep going back to the website, and you could keep clicking, and you could keep buying, but you had no control over it. And if you liked it at a certain point, if you went back a week later, it would look completely different. So those are the kind of examples that we were doing. What we were trying to get over was the fact that everybody using this technology could have their own individual products, their own unique products. And then Lionel, who is the industrial designer who did this, went on to create a whole series of other products. This Louis XIV copy chair of Philippe Starck's design, where the back was made out of individual nodules which grew randomly and selected, so you never had two chairs exactly the same. And jewellery, this is titanium sintered jewellery. And again, he would produce this in a run of 250 limited edition, every one of them individual, and that was the end of the production run. And all of this was very interesting, and it got a lot of coverage. But I thought it would be more interesting now to look at another system where the user did have some control. So I engaged a craftsperson who was more interested in this idea of uniqueness and ownership than perhaps the industrial designer was. And together we created this system called Automake. And just this gives an idea of where we saw Automake as a system fitting within the scheme of things. So on the left-hand side, we have the traditional mass production that everybody knows. You have a designer, and they create a design, it gets made in a factory, you end up with a standardized product, and a passive consumer goes and buys that particular product. On the other hand, we have the established model of craft production, where you have a designer maker, who then goes into the workshop and creates their designs, and then you have a series of products that are all variable, no two of them identical, and the consumer is perhaps a little bit more active because they are making a selection between those objects. Automake was designed to fit between those two parameters, so that it was a case of co-production, co-design between the maker or co-designer and the consumer as a co-designer. And they would together use an interactive digital process and create personalized products. That was how we saw it fitting into the scheme. So in this system, a user could go online and select a whole series of meshes in different shapes. And the most popular one was this torus shape. And the user can select and scale and stretch that shape. And they can also select from a series of little shapes that are shown there at the top and decide which ones of those they want. And they would fit together at certain points. And what would happen is the computer would then randomly go round, this little red dot is the computer checking where it can put another piece. And it would randomly build up a form filling up that envelope. And so the end result could then be printed out as a series of bracelets. And because you can scale that, you can use exactly the same process to make a ring or a necklace or a tiara. It's the same thing. You just scale it. So this was very interesting. Another way of going about it. And then we thought, well, rather than the computer connecting these little parts only at certain points, what happened if you used a gravity engine? That's a piece of software which makes those little particles act as if they have real physical properties. So we created an envelope in the shape of a bowl, which again, people could stretch and scale and twist, and then pour in loads of these little virtual pieces that then bounced around and settled and formed the shape within the envelope, and then it was printed. So I then curated an exhibition called Automake and Future Factories, which showed these two processes side by side. And it allowed people to see the differences in approaches between the user having absolutely no control except selection of when these processes started and stopped, and having some input and control over the system. And in the exhibition, which showed a whole series of physical artifacts and pieces of software, as you can see here, there was this chance for people to use this Automake software, and they could print out a 3D print of their final piece. So over the course of 6 weeks that the exhibition was on, the exhibition grew and grew as people who came to the exhibition printed out their designs and they went on display, which meant people kept coming back to the exhibition to show everybody what they'd done. And then they had a go, and it was very, very successful. And it's the fact that the users had that kind of interaction which is the key point. Because when we interviewed them afterwards as part of the research, you know, 7-year-old girl said, "Look at what I've designed." And that's really interesting, because everybody who used the system did not see themselves as a passive consumer. They saw themselves as an active designer. And that's the key point. That's a really key point. So this is why I was nervous about talking about this, because this technology is moving so quickly that every other day I get an email newsletter from 3D printing, various societies, and I always read something I didn't know. And I thought, I wrote this last week. It's going to be out of date by the time I present it to you this week. It's moving that quickly. But just some of the things that have happened over the recent past in this technology, people are printing replicas of Stradivarius violins that are perfectly playable. There's an electric guitar there that's 3D printed. A friend of mine has set up a company to print plastic guitars, acoustic guitars. It's quite amazing technology. Obviously, there's the example of personalization, where people can not only use the process like Nike ID, which I'm sure many of you are familiar with, where you can go to a Nike online store and select various colors of materials and surface details and make your own pair of trainers, to actually making a pair of trainers which fit your feet exactly. You know, they've been scanned, you scan your feet and you know exactly what you want, and a podiatrist may be involved, and you print your trainers. Problems of scale are starting to be addressed, so the fact that you can only print within a certain envelope is not stopping people. They're getting bigger and bigger. The Urbi is the first 3D printed car. It's the chassis, the body of the car and the chassis, all 3D printed. People are printing food. This is people printing their own pasta shapes and using. You give people this technology, the first thing they do is they go, instead of using silicone or plastic, they use cheese and chocolate and they go and print their own food. People are more creative than anyone gives them credit for. So people then start developing products to take advantage of that. There's obviously a desire to do that, and this is the kind of thing that appears. But in more serious uses, we have things that are happening in the medical industry which are really quite fascinating. Operations that would take 20 hours or more to rebuild somebody's jawbone are reduced to 3 or 4 hours, because you print the whole jawbone beforehand and then you put it in place, and the benefits from that from a health point of view are absolutely incredible. So there are really significant advantages rather than just developing new pasta shapes. And once you start printing in different materials such as biological cells, you start to replace ears by printing cartilage, and this one on the top left is a liver, and I'm sure there are many people who will be happy to know they might be able to print a replacement liver for themselves. Now this person on the left here is Adrian Boyer, and we were just talking about him before. I don't know if many of you in the audience have heard of him, but he's a researcher from the University of Bath in England, and this is one of the most exciting aspects of 3D printing technology that I can think of, because he developed this product on the left called the RepWrap, which is a replicating 3D printer. So you download the design for it because it's all open source. You download the design, you assemble the product, you turn it on, and the first thing it does is it makes another one of itself, which you then can give to somebody. And they plug it in and turn it on, and the first thing it does is it makes another one of itself, and so on. So his idea, quite an altruistic idea, is that before very long, everybody in the world, wherever they are, no matter how remote, would have the possibility to print their own products. And that raises all kinds of issues, obviously, many of which we're going to talk about tonight. And then the latest thing I've been hearing about is 4D printing. 3D printing was so yesterday. 4D printing takes 3D printed objects which are then changed by exposure to some catalyst or other. So you print a component in a straight line. When you drop it in water, it reforms itself into a different shape. So they're starting to explore advantages in that technology. But when I look at that, I think, actually, what I was doing 10 years ago was actually quite radical, because that's what we were doing. We were bringing that fourth dimension, the time element, into the design process. So these are all the fascinating things that are happening in this area. And this is one of the latest things that I've found, which is fascinating. This company, Nervous Company, it's called, started just by creating personalized jewelry. People could go online, they could use their programs to put a basic design, change it to what they wanted, have it printed out, and have a unique piece of jewelry. And that was quite fascinating. But this is what they're doing now. They're starting to look at 4D printing as a way of printing objects that have flexibility in them that we didn't previously think about. So I'll just let you just watch this for a second, but it's basically showing 3D forms that need this massive computing power to create the geometry that you print in one piece in a small space, and then they can fold out into much larger objects. And this is, when you start to look at this, you start to realize the potential for this kind of technology. So Nervous Systems were one of the first people to get involved in trying to commercialize this technology, and it's going very well by all accounts. So if we're going now to try and think about the implications of what we've looked at there, I think the most interesting aspect from my point of view is that we're entering what I've referred to in the past as a post-professional era. And this is where the technologies reach a point where the need for professional design input becomes compromised quite significantly. And as a designer and a design historian who's traced the history of the industrial design profession, that's of great importance to me, because I'm starting to see some really fundamental changes in the way things are done. So the new norms may be direct digital manufacturing. People may come to expect mass personalization, and people will expect to become involved to some level in the design process themselves. And when you do that, then we start to question, well, what is the role of a professional designer? where do they fit within the scheme of things if they're not completely responsible from start to finish for the design and production of a piece of design? And I think the most interesting thing is, if you just change the means of production, which 3D printing allows us to do, that has a big impact. But if you change the means of design, then I think you get a kind of compound impact. Much more meaningful impact can happen. So some of the issues that we might want to think about, if you include people in this equation, which goes back to that first exhibition that I showed you, where the people who were attending the exhibition saw themselves as the designers, then open design allows everybody that ability. So we have all these issues that arise: copyright, ownership, authorship. And the questions are, should we really think about giving up notions of copyright altogether? Who are the designers? Are they a designer if they use somebody else's system and have some amount of input themselves, but they haven't created the original idea? Where's the boundary between the creation of an idea and the adaptation of an idea? What is original? So all of those questions become open. Who will own the technology? Are we all going to have these machines that do this, or are we all going to use local sources of these, like local fab labs, urban fab labs? And I think there's a big question about responsibility and liability. I think we'll come on to that one. Now, some of these might seem a little extensive, but if you think of, for example, urbanization, the reason we have cities in the forms they are is because that's where things could be made. And that's where people congregated, because of the Industrial Revolution, to make things. And we've got the spread of urbanization because all around those production technologies, if you don't need to go anywhere to make anything, then why do we need cities? Do we need cities? On the left there, we've got no low-cost labor. What we're talking about is the cost of production, not the cost of labor. So if there's no advantage to going to another country where the labor's cheaper, then we completely change the economics of trade. Why do we need oversized trade? Why do we need import and export if everything that you manufacture is done at the point where you need it as a user? IP and copyright, we will need new methods of dealing in business in terms of IP and copyright. And how that will be tackled, I don't know. But people always ask that question of me: how are you going to make money as a designer if you don't own your own copyright, if you can't protect your own intellectual property? And that's a huge thing that we have to deal with. And other industries have had to deal with it and are suffering the consequences. Okay? And I think one of the big barriers is the access to the technology, I've said at the bottom here. We need to balance, I think, encouraging innovation, because when you get thousands of people involved in the design of an object, you get innovation that you wouldn't get if one person's designing it. So quite often I've had design students getting angry about this when I'm telling them this is the future, perhaps, of design. And they're saying, why should I study for years and years to become a designer if everyone can be a designer? I'm better than them. I've trained for 6 or 7 years. Said, yes, you may be better than one person that's out there who hasn't been trained. But are you better than 100,000 people working together? Think about that. Is that possible to be that good? So that makes them think a little bit. Yeah, we might have to operate in a different way. And one of the barriers that I see in all of this is the access to the technology, because at the moment, you need to have 3D CAD modeling skills to some extent to do this kind of technology. And the reason I was doing those pieces 10 years ago was trying to design systems that people could interface with and create their own objects without having any ability to do 3D modeling themselves. So the designer's role moved to creating a system for other people to use, rather than being responsible all the way through. So I think, just to kind of conclude with a few points, the full potential of these technologies, I think, will only be realized when we take 3D printing hand in hand with open design processes and practices. And I think we have to see it as not only an alternative to mass production, but a return to much more craft-based values of production, where the person who's making the product is much closer to it. There isn't that distance between the design and the mass production and the passive consumption anymore. The designer and the maker and the consumer are either going to be one or extremely close together. And I think just the last thing I would say is that there will be a huge change to some level in design and manufacturing. On the one hand, we've got the people who say everything in the future is going to be 3D printed and everyone's going to do it themselves. There won't be anywhere in the scheme of things for large corporations, which is extreme. And on the other, we've got people saying, well, no, we will always need those large-scale production processes, and this is a fad. It's something, yeah, you can print your own mug, but so what? You know, the real naysayers. So at the moment, there are two quite opposing camps of where this is going. And I think if we're realistic about it, we can see that the future is going to be somewhere between those two extremes. And what we need to do is figure out where those processes are going to interlink and where we're going to interface with them. I think I'm going to leave it there. Thank you very much.